It's one thing to say, when it's really sunny in California, I can use those electrons to power industry. But what about in the middle of the night? What about if there's a 4-day storm where there's no sun or no wind? It's those circumstances where the manufacturing sector still needs reliable energy, but wind and solar alone can't do it. So that's why you fundamentally need storage. Fossil fuels have driven all of our civilization for the last couple centuries because of two things. One, they can get really, really hot, so they can provide heat or they can generate power. And two, they're super cheap. And so our technology does the same thing, but with zero emissions. No one had a good solution to heavy industry. And that's because it's a very hard problem. You need reliable heat and you need reliable power around the clock. And the only way we can do that today in a cost-effective way is with fossil fuels. So the combination of it's the biggest problem that we have facing us, probably as a species, and there's no one really providing a good solution to us, that made a perfect storm of problem we wanted to work on. Our technology solves this problem by eliminating the variability of wind and solar. So the way that works is you take that solar electricity or that wind electricity when it's available on that sunny or windy day, and you use it to resistively heat blocks of carbon. So what does that mean? That means you basically just run this extra electricity from wind and solar through a toaster coil, basically a big industrial toaster coil. And just like the toaster heats up your toast, this toaster coil heats up our blocks of carbon. But it heats them up to such high temperatures that they're glowing white hot. And we store those glowing hot blocks in a well-insulated container so that we don't just leak that heat back to the environment, just like you have a thermos to keep your coffee hot. But here's the fun part. When you want to extract that stored thermal energy, or when you want to discharge the thermal battery, you open up a little shutter or a door on the side. And that allows that really intense thermal glow coming off that hot carbon to be released from the system. So now you have a beam of really intense thermal glow coming out of this system. And you can do that on demand. You can open the door, release the light, or you can close the door and keep holding that energy. When you open the door, there's two things you can do with that beam of really intense thermal glow. The first thing is you can use it to directly deliver process heat to heavy industry. And we can do that up to about 1500 degrees Celsius. And that's really important. Our storage temperature is so high that we can supply industrial heat to some of the hardest to decarbonize industries, such as cement, steel, lime, petrochemicals, glass, etc. The second thing you can do with that beam of intense light is you can use it to generate electricity. And the way that we do that is with a modified solar cell, and this is called a thermophotovoltaic panel. That's very similar to a solar photovoltaic panel, but instead of converting sunlight into electricity, it's capturing that thermal radiation coming off of the hot carbon, and it's converting that into electricity. So in this way, we can take our stored energy and we can deliver industrial process heat or electricity on demand. We really see energy storage playing a critical role in the evolution of industrial energy. And in particular, in the future that we see it, every single industrial facility is powered by wind and solar electricity with a thermal battery on site. So the way Antora plays into that is providing that thermal battery and converting that variable wind and solar into reliable round-the-clock heat and power. We were super grateful to the CalSEED program at Antora because they were one of our earliest supporters. When we were a very small company with very few resources, CalSEED believed in the idea that we were building and funded us, and that funding was critical to our development. My name is Justin Briggs. I'm one of the co-founders of Antora Energy.